Gulfstream GV, Aircraft Fire Protection and Fuel System. Introduction: Fire Protection. The Gulfstream Fire Protection System utilizes a combination of fire detection and suppression instruments in order to both alert the flight crew to the presence of a fire on the plane and as a means for both automatic and manual fire suppression utilizing instruments from the cockpit. In most cases, the system is able to detect fires located in critical areas such as the engine nacelle, and the APU area normally inaccessible during flight. However, it is also capable of detecting smoke in a plane's baggage and equipment area which are accessible by the flight crew. In such cases, the Gulfstream comes equipped with halon and water fire extinguishers which can be utilized to suppress fires without having to trigger any onboard automatic systems. Smoke detection. The Gulfstream utilizes a smoke detection system made up of a series of smoke detectors placed in high-risk areas within the interior of the aircraft. On average, these smoke detectors utilize photoelectricity in the form of a constant stream of light to detect variances in air consistency. If a sufficient degree of smoke should enter into the detector, an alarm will sound alerting the Gulfstream crew as to the location of the fire. It must be noted though that this particular system was not designed to detect high temperatures, and as such in the instance of intense temperatures with little smoke, this system is rendered useless. Based on the detector's inherent limitations, other methods of fire suppression and temperature fluctuation detection are present within various areas of the aircraft to act as a redundancy system in the event that the smoke detection system malfunctions. Fire suppression. The fire extinguishing system on the Gulfstream consists of a portable fire extinguishing system for cabin fires, an external engine fire extinguishing system as well as an APU fire suppression mechanism. The portable fire extinguishing system consists of the halon and water fire extinguishers located near the cockpit and towards the rear of the plane, while the external engine fire suppression system utilizes a system mounted on the tail of the plane which fires a single-shot extinguishing agent into the engine in the event of a fire. This system is triggered utilizing an engine fire pull handle located within the cockpit that not only triggers the fire suppression system but also shuts off all electrical power, fuel, and hydraulic fluid going into the engine in order to prevent the fire from feeding off of the fuel and electricity. Lastly, the APU fire extinguishing system, similar to the engine fire suppression system, is activated via the cockpit overhead panel which releases a single-shot fire suppression mechanism that is located near the tail compartment of the plane. Introduction: Fuel System. The fuel system on a Gulfstream utilizes two fuel tanks located within the wings of the plane which feed fuel into the dual Rolls Royce BR710 engines. On average, the plane has a total fuel capacity of 6,118 gallons with 38 transistorized fuel level probes enabling the pilot and ground crew to measure the quantity of fuel within each fuel tank. The Gulfstream can utilize either gravity or pressurized fueling mechanisms depending on the refueling equipment located at the airport, with the ground crew utilizing the ground service control panel to determine the current fuel levels of the plane. Fuel storage mechanism. When fuel is pumped into the wings, it flows directly towards the center of each wing due to the 3-degree angle of the wing itself, which causes fuel to flow towards the lowest part structure. As the fuel reaches a sufficient level, the air and fuel vapor located within the tanks flow into various intake valves which act as a mechanism for preventing excess pressure or vacuum from accumulating within the tank itself. This ensures that fuel flows freely from the tanks towards the engine without any undue pressure interrupting the process, which would be disastrous. Fuel cross-flow mechanism. During normal methods of operation, Gulfstream utilizes a fuel cross-flow mechanism in order for either fuel tank to supply fuel to both engines or to allow fuel to enter from one tank to another. The reason why this particular method has been placed into the Gulfstream is due to the inherent weight of fuel and how excess fuel in one wing may cause navigational problems during normal flight operations. While there is a system of valves that enable fuel to be drained from the plane, put fuel into the plane, and apply or release pressure from within the wings, the fact remains that both tanks should have a relatively equal amount of fuel. Too much weight on one side of the plane could cause the Gulfstream to have a haphazard method of flight, and as such the fuel crossflow components allow the tanks to be relatively equal while at the same time allowing adequate fuel to be supplied to the engines. Fuel indication system. One of the most important components of Gulfstream's fuel system is the fuel indication system, which gives constant readouts to the crew of the current level of fuel in the left and right tanks of the plane. This system contains a variety of sensors that, aside from indicating the level of fuel in the tanks, gives readouts on the temperature within the tanks as well as measure overall fuel density. The reason for such precautions is that any imbalance in tanks, whether in the form of excess fuel and pressure, rapidly climbing or decreasing temperatures, or the fuel suddenly taking on a denser consistency, are indicative of problems that occurred either during the refueling procedure or during the flight itself. If such problems are not immediately corrected, this can result in either stalled engines, the fuel literally freezing or bursting into flames, or fuel lines corroded with denser fuel consistencies.